Welcome, sir, for our ICMTA 2021.
Thank you, ma'am, for inviting us here. May I call upon Mr. G. Grahathurai, Deputy Director, Launchpad Machine Management, Satish Dhawan Space Center, ISRO, Sriharikota, Andhra Pradesh, for the inaugural address.
Good morning, madam. Thank you. I hope I am audible.
Yes, sir. Yes, sir.
Yes, sir.
Dr. A. Govindarajan, Professor and Head of the Department of Mathematics. Professor Napoleon, Dean CET. Madam Dr. Parvati, and all other dignitaries, mathematicians. Once again, very good morning to all. It is indeed a great pleasure for being a part of this International Conference on Mathematical Techniques and Applications, ICMTA 2021 by SRM University. I will be delivering this lecture with respect to mathematical applications in space science. Mathematics is there everywhere. Everything is related to mathematics, whether it is religious or scientific. We ask small kids, how many chocolates do you want? This is how we start teaching mathematics even to kids. Nothing exists in this world without math. Everyone uses mathematics in our day-to-day life, and we do not even realize it. We will be ungrateful if we do not recollect our great Indian mathematician Aryabhatta, Bhaskara, and our Srinivas Ramanujan. Aryabhatta was born, all you are aware, of 476 CE in Pataliputra, and he is famous for putting out concepts like lunar eclipse, solar eclipse, rotation of Earth on its axis, etc. Srinivasa Ramanujan had made immense contribution to mathematics in the area of number theory, infinite series, etc. My lecture is a tribute to our great Indian mathematicians. There is a mathematical, analytical, geographical, historical connection between math and space science. Science itself is the interpretation based on math only. Math is the backbone of any form of science. Everything in space science is governed by mathematical equations. Space science is nothing without mathematics because we have to calculate distance of heavenly body, speed of the planet, how fast it revolves, about its axis, etc. Mathematics is used in space science to calculate the routes for satellites, rockets, and space probes. Mathematics is used extremely in global positioning system. As everyone knows, nature follows some mathematical trends. For example, Earth's motion around Sun, occurrence of eclipse, full moon day, no moon day, etc. Have you ever wondered how the distance between the Earth and the Moon is calculated? How the distance between the Earth and Sun is calculated? How the radius of Earth is measured? It is not calculated just now. Thousands of years before, it was done, and more accurately. It is done using the concept of math and bit of logic. In 17th century, Kepler studied the planet's orbits mathematically, while Isaac Newton described the planet's motion in relation to one another. Newton equations are still used for calculating gravitational force. There is a strong connection between mathematics and space science. In the 200 BC, the Greek philosopher devised a simple geometric method to measure the radius of the Earth. He estimated the radius of Earth by looking at two shadows at different locations on the Earth. Mathematics and space science cannot be viewed separately. Astronauts use mathematics and everything is based on prior calculations. One of the NASA astronauts said, "It should be evident that each step in my career has rested on a firm foundation in mathematics." For me, the study of mathematics was the key that opened the doors to the universe. Astronauts use math in order to make precise mathematical calculations from how the spacecraft leaves Earth's atmosphere and to how the astronomers pilot the craft. Mathematics used enormously to calculate the movement of space shuttle to space station. Designers use maths to calculate distance, speed, velocity, and their own safety when creating spacefaring vehicles. The word space, like many mathematical terms, is used throughout mathematics to define different concepts such as vector space, topological space, metric space, linear space, etc. There are too many uses of mathematics in space science. It includes calculations, measurements, finding probabilities, etc. Probability is one area in mathematics which is extremely used during rocket launches. Probability is a measure of expectation that an event will occur or statement is true. The value of probability is between 0 to 1. Higher the probability of an event, the more certain that event will occur. So measurements during rocket launch, range, azimuth, elevation are measured for knowing the path of the vehicle. Mathematical modeling techniques like mathematical models are used to design aerospace vehicle. Mathematical modeling techniques are used in meteorology to determine the day of launch parameters. So coming to the space debris is defined as all non-functional human-made objects, including fragments and elements thereof in Earth orbit or re-entering into the Earth's atmosphere. Millions of space debris is available. Okay. You can see there are 13,000 debris objects of varying size. Space agencies all over the world are continuously tracking the trackable space debris and developing removable strategies. Evasion of such scenario require accurate orbit prediction and collision prediction. Accurate collision prediction has two significant components. One is the data collection, next is the orbit determination. The accuracy of these two components hugely influences the accuracy of the result, sometimes even exponentially. So now I am the deputy director of this range operation, where we will be taking care of the total launch once the vehicle is in the pad and once the countdown starts, and we will be totally handling the range operations for the launch. So just before we decide, I will take two examples in our range operations, how the mathematics are used in our range operations. First, for any mission when we select, when we design or when we announce, first the trajectory generation. The trajectory generation involves integration of differential equations, transformation of vectors to desired coordinate frames using series of transformation matrices. Integration can be done using Euler method, Taylor series based on the requirement. Next is the look angle generation. For tracking stations, there are so many tracking stations, involves the transformation of trajectory data from Cartesian coordinate system to the polar coordinate system. Then coordinate transformation matrices are derived from series of trigonometric rotation equations of the coordinate system. Then, very important, this impact point prediction. For identifying the danger zones ahead of launch and plotting the instantaneous impact point in real time during launch involves integration of current state vectors using Taylor series till impact and coordinate transformation using series of rotation matrices. Next is the risk analysis. For any mission, trajectory involves computation of casualty area using fragmentation pattern, probability of failure, and casualty expectancy. Real-time data processing of radar tracking data. It involves the correction of radars, systematic errors, filtering of noises using Kalman filter, and the correction of atmospheric refraction errors before transmitting to displays. Next, coming to the prediction and the extrapolation. It involves the integration of differential equations to find the current state from where previous state or further state from current state. Generation of program mode. Data for satellite tracking involves integration of satellite orbital parameters using Newton's law of gravity and Kepler's equation considering various perturbations. Plotting of parameters in various displays is done using conversion of signals signal voltage values from sensors to engineering units using scale factor and offset, and further converting it to pixel values to be plotted in the display screen. And coming to the signal processing, it involves numerous mathematical operations like modulation, which is the process of converting data into radio waves by adding information to an electronic or optical carrier signal. Yeah, carrier signal is one with the stereo form. And coming to encryption and decryption, encryption uses a mathematical algorithm to scramble or encrypt the data and then uses a key for the receiving party to unscramble or decrypt information. Then let us come to another application. We have for 6 radars. One more radar, there is a multiple object tracking radar. It will track multiple objects. In MOTR, let me explain how the mathematical techniques are used right from the signal generation to target detection. A small arc tracking data of space debris is used to predict its path for 3 to 4 days. This is possible solely by modeling various perturbations mathematically. In radar, we use from the basis of Laplace transformation to advanced Bayesian filtering algorithm, astrodynamics laws. MOTR is multi-object tracking radar, generates positional information of target with respect to time. This time series data is collected as spatio-temporal data, that is spatio-tagged with the time. And the following are the different mathematical techniques we use in the different subsystems of radar. First, let me start from the antenna. The transmitted and received signals are represented in complex sinusoidal form. Several amplitude weighing algorithms are used to tune the radiating patterns, such as Taylor series, Blackman series. These are all the things I have named few. Coming to the beamforming algorithms are used to form proper radiating pattern. A factor of radiating pattern is a mathematical model to design the complete beam formation. And coming to the receiver signal is converted from the time domain to the frequency domain using Fourier transformation. Pulse compression involves the time domain convolution of radar signal. Next, coming to the data processing. Data processing of radar data demands intense statistical analysis for which various mathematical techniques are used. Coming to the coordinate transformations from Earth coordinate system to the celestial coordinate system, tracking of aircraft requires Earth domain. When it comes to tracking satellite, we require celestial domain. And Bayesian filtering algorithms, all detections are associated with the Gaussian noise. We remove this by applying various filtering algorithms. Next, coming to target association algorithms, every tracking has certain uncertainty. This is modeled using probabilistic theory. Various probabilities association techniques such as JPDA, IMM are used to establish tracking of target. To dynamically analyze target rates, we use first order differential equations such as range rate, angle rate. This involves differential equations in various coordinate systems. Coming to orbit determination, 300 seconds of radar data enable us to predict the satellite path for 3 days. This is achieved by converting positional information of radar data to orbital elements. This involves rigorous mathematical models like the two-body propagation to J2000 propagation, where gravitational parameters of Earth, Moon, and all other planets are modeled. Several perturbation forces like atmospheric drag, solar flares, and Earth mutations are modeled mathematically. Differential correction techniques for determining the orbit of the satellite. So these are the just two applications I have taken in range operations. There are so many mathematical applications are used in our range operation. This is one of the entities in ISRO. There are so many entities like this in ISRO. So you can understand what is the mathematics used in space. So coming to closer, so a good understanding of maths in everyday life is essential for making sense of all the numbers and problems life throws to us. It's almost impossible to get through a day without using mathematics in some way. So because our world is full of numbers to handle the problems to solve. In my talk, I just touched briefly about the mathematical applications in space science. I think surely you would have given, you feel, yes, how mathematics is essential for space science. Space is infinite. Space is boundless, three-dimensional extent. So in mass, infinite set is a set which is not having finite number of elements. In this context, the application of mass in space science is also infinite. Space science and mathematics are inseparable. Thank you for everyone giving me for this opportunity. Thank you once again.
Thank you so much, sir. I thank sir for the address and giving all possible facts for the importance of mathematics, delivering a special note on great mathematicians, how maths becomes an essential tool in space, adopting various fields of maths and perfectly explained.
Madam, 1 minute, madam. Professor Ismail Nasir Gangul, welcome, sir. Professor Ismail Nasir Gangul, welcome, sir. Hello. Can you hear me, sir? Hello. Professor Ismail Nasir Gangul, you are welcome to our inaugural function, sir. Okay. Madam, proceed, madam, please.
I'm sure, sir, you have made us all lift our heads high as mathematicians. Thank you so much, sir. Now, let us view the release of the proceedings of ICMTA 2021.
Now, actually, our Dean CET will be releasing the proceedings, and our chairperson, School of Applied Sciences, will receive a copy. First copy.
Sir, was it visible?
Yes, yes. I thank our Dean CET for releasing the proceedings. I also thank our Dean School of Applied Sciences for receiving the first copy of the proceedings. I also thank the coordinators for receiving the second and third copies. Madam, next, madam.
May I now request Dr. E.P. Siva, Assistant Professor, Department of Mathematics, SRMIST, for thanking the gathering.
Thank you, madam. Very good morning to one and all present here. On behalf of Department of Mathematics, Faculty of Engineering and
Siva,
Technology.
sir?
Yes. Yes. Am I audible?
Yes, yes. Proceed.
Yes, sir. I have great pleasure in performing that pleasing duty of signing. Thank you all who have constructed and worked for that second international conference for EICMTA 2021. I thank our Honorable Chancellor, Pro-Chancellor, Admin, Pro-Chancellor Academics, Vice Chancellor, Registrar, Dean, CAT, Chairperson, School of Applied Sciences, Dean CFS, CFH for their consent and interest in providing us in the right atmosphere to conduct that international conference second time in the online mode. I thank our chief guest, Mr. G. Grahadurai, Deputy Director, Range Operations, Launchpad Missions, Management, Satish Dhawan, Space Center, ISRO, Sriharikota, for accepting our invitation to be a chief guest for that inaugural function and delivering the inaugural address. I thank all the plenary speakers for accepting our invitation to give plenary talk in various fields of their specialization on 3 days. I particularly thank to our Dean Research to accepting to give the presidential address. I thank all the research scholars and participants from the both Tamil Nadu and other states and all over India, and many papers have come from that abroad to present their research articles. I thank them for their emergence and spirit to present the research article in our conference. I thank Vishwa and Devji for their generous sponsorship for that past 8 years. I thank all the reviewers who reviewed mathematical research article. I thank all the members of organizing committee, academic committee and advisory committee for their valuable suggestion to give us every now and then. I thank all the other department HODs and deans for their presence during the inaugural function. I thank convener Dr. A. Govindarajan, our head of the department, College of Engineering Technology, Department of Mathematics, for his constant support and suggestions in organizing that conference successfully. I thank all the professors of our department for the encouragement, guiding us in the right direction. I thank our department colleagues for their cooperation in carrying preliminary arrangements and their punctual in completing all the duties in time. Last but not least, I thank all the administrative staffs, maintenance staffs, and the DTP section. Thank you very much, one and all presenting. Thank you.
Thank you, sir. Once again, I thank you one and all for making your valuable presence for the inauguration of ICMTA 2021. Kindly join us for the invited speaker talks by the respective links provided. Thank you.
Sir, once again, if you are switch on your videos, I'll take one snapshot, sir, please.
Yes, yes. Please, all of you show your video so that you can have a photo of your face. Ismail Gangli, National Sir, welcome, sir.
Good morning. Thank you.
Good morning. Good morning. Good morning. Good morning.
Kodandram, sir.
Gangul sir, good morning sir.
Good morning, my friend.
Dr. Shobana sir from Max department. Good morning,
And
sir.
nice to see you again.
Thank you sir.
Kodandram, sir.
You take as many photos as possible, Kodandraman. It is going to be a
Okay,
proud moment for us.
Just two minutes, sir. 2 minutes.
It is going to be a proud moment for us. Dean sir, you also, Dean CD sir, Dean Research sir, Dean Napoleon sir. You can also show your video, sir. Napoleon sir.
Okay, wow.
Jyoti Kumar sir, welcome sir.
Sir,
Jyoti Kumar sir.
சொல்லுங்க கோதண்டராமன் சார், சொல்லுங்க சார் கோதண்டராமன் சார்.
Sir, okay, sir. Thank you.
Okay.
Thank you very much. சார் HOD சார்.
Yes.
சார் அந்த ஸ்பெஷல் டாக் வந்து எல்லாரையும் வந்துர சொல்லுங்க சார். அது லிங்க் இல்ல.
Okay. Sir, I request all the dignitaries to come for the special talk. That is invited talk. The link is sent to the members already. Please join us in the Zoom platform for the invited talk. The respective links. Okay. Thank you, sir. Thank you. Shall we stop recording?